Howdy, everybody, and welcome to an episode of not NES GameMaker, but it is definitely GameMaker related. So today we are going to be talking about Firebase. So a lot of people like to have a high score table or some sort of minor online functionality, such as shared information between different accounts or something in their games, right? So how exactly do you go about doing that if you don't know how to set up your own server, or even if you know how to set up your own server, maybe you just don't want to be bothered? So that's where Firebase comes in. Firebase is what's known as a headless server, or just serverless server. You can use online functionality such as databases without actually having to set up your own server. So what we got going here? You come over to firebase.google.com, and if you have an account, log into your account. If you don't, set up yourself a Google account and click on Get Started. So as we can see, I've already set up a previous project here, but if you're going to be making your own, you're going to need to hit Add Project here. Let's come up with a name. Table for YouTube tutorial. Table for -- tutorial. That sounds great to me. Google Analytics, I don't really care about it, but you can have it turned on if you want. Don't really need it for our purposes. So we're just going to hit Create Project to minimize the amount of actual effort that we actually have to do to get this running. While this is setting up, we'll just come over here to a project that I've already completed for you. Presents the if you can see me right now, I'd be making hand motions like I was some sort of cooking show host, presenting my freshly made casserole. So you'll come up with a project overview over here. And you'll have different options over here: authentication, cloud Firestore, real-time database, storage, etc. The main thing we're going to be focusing on here is the real-time database. So let's click on this. As you can see here, we have a database and a whole bunch of names that are in this database. And you're probably going to be wondering how in the world we get all that in there. Well, that's the GameMaker project, and we'll show you that in a little bit. Let's see if this is done now. Okay, yes it is. So yeah, come on down. You have to hit Create Database. You can start in test mode, but it doesn't really matter. I'm going to show you how to set up the rules and stuff here in a second. It starts off with null. That just means if you were to query this database for information, it would return null because there's nothing in there. So what we want is a table, and we want to be able to get unique user IDs into this table that contain information about players, such as a name that they submitted and a score that they submitted, and then be able to retrieve that data to display a high score in game. And there's a lot of other stuff that goes into this. But to get us started, we're going to jump right into the rules, which is the most important part here for us as far as it goes. The rules are a bit of a JSON setup here. Rules, read, write. Currently, by default, they're false, which means that if you were to pop up in the rules playground and just run this, means that you can't read or write anything to this setup here. So what do we got going on over here? On the other side, we have the setup that I've set up for the rules here. So we want to set up our rules like this. Let's see, we have rules, and then we have our sub-rule read and our sub-rule write. In this case, we have rules, and we have our sub-rule read, and then we have our sub-rule $UID. And then there's a subrule to that subrule, which is write. So in this case, we've set up read to true, which means that anyone who can access this database can read the information from the database. So if anybody can access this URL, they can read all of this information. And technically, I don't even need to have that set up because I changed some of the setups so that you need that. But anyways, it doesn't really matter. People can read your high scores, who cares? But the $UID is a variable which says, okay, well, you have to actually have the corresponding UID in order to write. And as we can have it set up here, we have it set up further. $UID equal to auth.uid, or in this case, triple equal to. And we have this set up. Don't forget your, you have to have the little comma right there, but it's not right there, or comma right there. It's all fun and games, but it's really hard to get set up to some extent. We also have this .indexOn variable we've set up here. And we've set it up so that we can sort based on the score right there. So we're going to need that information, and that should be all you need to be able to set up your database. So I'm just going to copy it over here, publish it, and it's good to go. And we have this table with nothing in it. So to get it started with, we'll just add a child here, give it some random value. You have to actually do this because if you don't do it, it won't let you insert anything into the table. You have to have at least one name in there to start. And that was name and score. There we go. All right, so you might be wondering about the authentication. Well, the authentication, I don't believe it actually really matters very much at this point. We actually have to do setup sign-up method. Come over here. We want anonymous because we don't care too much about actually having them log in, but with this information I give you, you should be able to create an actual login as well. So you got that going for you. You can use email password, Google sign in, or Twitter sign in. The information is all actually over here in the database for the help database. You can access that from clicking on the help and clicking on Firebase help. Developer docs, any of these things. You want guides and references. They'll be your important part here. And the reference for the REST API is the most important part, I think. Let's see, services, blah, 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 REST. You'll need to look into the REST API because GameMaker doesn't have a built-in setup. There it is. Real-time database. Real-time database user auth. So these are all the important things to know. Oops, not there. Just want the authentication and user management. There we go. That's the one I really wanted. So I got all this information from in here that I'm going to use in the actual GameMaker project. So exchange custom tokens for an ID and a refresh token. Using the exchange refresh token for an ID token, and then you can sign in with an email, sign in anonymously. That's the one that I actually care about. and it tells you the HTTP and all the information you need to send in a query in order to do a sign-in. Remember when I was talking about IDs earlier? This is that ID. Well, it's not the ID. It's a token that allows you to submit data to your database as a user. So anyways, I think that's all the information you need to be able to get this thing started. So let's come back over here to the real-time database. And let's actually go into the project itself now so we can take a look. This is actually really kind of simple, but at the same time very complex. We have Object Firebase Database Controller, call it whatever you want, that's what I called it, and a room. I didn't really do anything to the room, I just dropped the database controller into there, and don't you forget to do that. So we got create event, cleanup, steps, draws, etc., etc. And we'll go over it as we go into here. Keep you zoomed in so that you can make sure that you can read the code here. Oh yeah, I should make sure I make the disclaimer here that this code is not secure, in that if somebody was sufficiently motivated, they can decompile your game, get the keys, and then send in whatever data to your database that they want. Which probably doesn't matter for the most part, because most people who are actually interested in your game are probably going, well, pirating is popular and whatnot, but if you really care about preventing pirating, you're basically going to have to make your client a dumb client that only gathers up input and sends it off to a server where you use scripts and stuff, which are more advanced than what I'm trying to set up here, to actually do all the input and managing all the information. But that's way beyond the scope of this. We're just making a simple high score database, and we don't really care if somebody's editing their score, give them 1 million points, because, well, theoretically this is supposed to be a quick setup for having a high score database in your game jam projects or something like that. So, you can use this in a production project, but just, I wouldn't use it for anything that you want to keep secure, like a name with information about if they paid for services from your game or something, because then somebody could hack that and then pretend that they have all the jewels or whatever they want, or that they have a premium account or whatever. Which, I mean, again, if you don't care too much, it doesn't really matter. It depends on how much you actually care about how much people are hacking into your project. So anyways, now I've gone over that disclaimer. We have the enum set up, and we have a table column for naming points, enum request type. This is the most important one here. We have authorization requests, submission requests, get requests, update requests, and refresh requests. So this would get us logged in. This would refresh our login if our login expires, which it does naturally after 1 hour. I've set it up here so that after 59 minutes, we'll do a refresh. Then we have a submission, so we want to submit our score. Get our current high score if we already are in the database, to make sure that we have a new high score to submit. And update, which just gets our high score table and lets us see what the current high scores are. So we have our HTTP set up. Request IDs, we're going to create a map for that. Timeout timers, again, a map for that as well. And you could probably use lists and stuff too, but in this case I just set up maps for everything because I'm crazy. Database URL, that will be this right here. Our API key. If we go into our project and project settings, web API key, right there. just insert that into here. Authorization location, this should be the same. And our refresh location, this should be the same as well. These are from the manual. And it tells you that information right here. And remember to add in our API key to these token setups. Our ID setup. Again, there's a million ways that you can customize this. This is the most basic setup I can figure out, but with this information, you should be able to create your own setup fairly easily. Again, so you have your authorization token, which you need to keep, your refresh token, which you need to keep, your user ID, which you need to keep. With this user ID, you can actually just kind of make your own up if you really feel like it, but you don't really need to. And let's put in a session time to live. That'd be 3540, or 1 hour would be default, and we put it slightly under that. There's actually a part of the authorization protocol that tells you how long your time to live would be. But unless you're actually changing that, which you probably shouldn't be, you can just use this. Then refresh, session refresh time, window refresh our setup, our session. We'll be using that to tell us when we need to refresh our session. As said, I guess. General setup, high score array. This is data that you're exfiltrating for use in other objects in your game, most likely. In this case, I'm going to be using it all here in the draw event because I'm just going to draw a really simple database. A timeout limit, so in this case I have 5 seconds. That should be more than enough for how long before you time out a request. Retrieval limit, so how many records you want to retrieve. So in this case I'm only retrieving 10 records, but you could get 20 or 30 or however many you want. And then this is just stuff for the project. In this case, I'm randomly generating a score and a username. And you'll be using whatever is in your game for that. Don't forget your cleanup. Destroy your request IDs and your timeout timers. And let's jump over to the draw event real quick, since we can just kind of skip over this real quick. This is if you want to actually bother making it exactly the same way I'm doing, but you'll probably come up with your own system. We have a little bit of information about how to use the project. Just set up our text draw, and if our DS map is not empty for request IDs, so if there's a current request out there, then we need to get the first request in the map, turn that request name into a real, which we then throw into this switch and bounce it against our request type enums. So this would be 0, 1, 2, 3, 4, and we're inserting the request types into our map as the name. And like I said, we can pull it back out again to get that information. This just changes what information it's telling you about what you're trying to do. In this demo, you can kind of hit a bunch of buttons at the same time and cause multiple requests to all be set up at the same time. But most of the time, if you're setting things up, if you're doing things inside of a live game, you're not going to be giving the player manual control over if they can hit the left key to submit and hit right key to get an update and press shift to grab a refresh all at the same time. You aren't going to be letting that. Most of the time these requests will actually be pretty linear, so there'll only be an authorization request, then only a submission request, then only a get request, then only an update request, then only a refresh request, or whatever. Oh, my voice is getting kind of tired at this point, so let's keep going, see if we can get through all this. So if is array, so We can see right here the high score array. We started off as no one, but once we actually have array information in there, then we draw the high score array out. This is just a simple repeat over the size, drawing it in there. It's nothing special. So that's that part. Let's see. Let's create, clean up, draw. Key space just adds some points to your score so that you can submit a new high score. So nothing really important going on there. So next up we have the actual meat and potatoes. So the step event, each of our user events, and our HTTP async event. As far as it goes, this setup is for 2.2 and previous. In 2.3, instead of using user events, you could turn it all into functions and have this function set up in the create event or someplace instead, or as a script or something if you want. But in this case, it doesn't really matter too much. And even in 2.3, you could probably do it this way too. It probably doesn't matter too much. We're just going to be sending our authorization requests from each one of these user events. So let's go over to the step event first. So we have a couple different things that we're going to be doing. We have our get latest high score if there's no current request in progress for a high score. Send new player score to the database. Send a new player score to the database. And our timeout timers and our session refresh. So let's get started over here with sending a new score to the database. So if the player presses their left mouse button, or actually let's go with get first because it's even simpler. So if there is no request in the DS map currently, and we right click our mouse, then it will send an update request. So if is undefined, DSMap find value, request IDs, request type.update. So if there is no request type.update map value in this map, then we can send an update request. So request update type, update high score database. Show a little debug message that's really useful. Our body is nothing. There's no body needed for getting it. For the headers, we create a map. It's empty. We're not really putting anything into it. Again, because we're just sending a GET request here. And that would actually be wrong. Because that's the comments for the submission rather than the GET. So here's our request when we actually build it. We have table underscore get ID. Our HTTP request is database URL plus .json. That tells it to get the entire database as all the readable information as a .json. Then we have order by, and we use score and limit to last string retrieval limit. And timeout, string timeout limit. S tells it seconds. So this string tells it to order all of the, tells us to, okay, so we want to get the JSON, but first, before you return the information, sort it by the score. And then we want only the last 10 or however many retrieval limit scores, which would be so when you sort it by score, it automatically sorts from lowest to highest. Then we do string retrieval limit, and timeout is how long before the packet itself times out if for some reason the server isn't working. And it's basically kind of the same thing as our timeout setup that we got. But yeah. Throw in our header map. Oh yeah, we are using get because we're getting the information from the database here. Our header map and our body, just throw them in. DS map replace request ID. So if there was a previous request type and we request it again, replace our old request type with our new request type. And what that does is, so this generates an ID number, this function here, and puts it into there. Then we put that ID into our request ID map. And if we had a previous request, it discards the previous request, which will time out, and we don't care about it because we're looking for the new, most recent request. Which could be an issue if you don't want people being able to send infinite requests to your server, but at the same time, they should only be able to send it once because you're controlling when they actually send a request. They're not being given manual control, hopefully, because that would be bad. Var underscore timeout is equal to date get second of year, date current time. So that gets our current time as seconds of the year. Then we add in our timeout limit to that. And then if our timeout is greater than this time, which would be for at a year, then it rolls it back by that same amount so that we start over for the next year. This would only really be important if you were sending a request within an hour of the end of the year. So at least I got it in there. I thought of it at the last second. It probably doesn't account for leap years, though, or anything interesting like that. So there could be some very minor issues at that time of year, but that's up for you to figure out if you actually really care about it at that point. Then again, replaces into our timeout timers, same request ID, and throws in our timeout there. So now we can keep track of our timeout update there, and then kill the header map. And speaking of timeouts, come over to our timeout region. If our timeout timer map is not empty, so if there is a timeout that's being currently kept track of, then get the size of our map and get the key to the first position in our map. Get our current time as seconds again. And let's iterate through our DS map. Get the time from the timeout timers map at our key position. If is undefined time, then continue. So if something happened and our request disappeared, because the async event can happen at any time, so we could get the information right here, and then so it would have found that our map wasn't empty, but then by the time we got to here, the async event triggered and the map got cleared out. So now all of a sudden our map is empty. Then our time would be undefined. So we'd have to say, "Oops, looks like we don't actually have a timeout timer to time out anymore." So then we'd continue out to get rid of that. If our timeout is equal to date compare date time, so we compare our time to current time, and if our if the timeout is less than or equal to 0, then it has timed out, and we can inform ourselves, throw an AI for auto retries, disconnects, whatever. And in this case, I just there we go. I just throw in a bunch of little auth request timed out, score submission timed out, etc. Little information bits. But like I said, you could throw in your own system for auto retrying and so on and so forth if you feel like it. Then remove the request from the map. And key is equal to DS map find next. So if there's another request in the map, move on to that next request and try again. Close region. Alright, so I hope you got all that information from there. You should have been able to see it all, I hope. And it's all zoomed in, so what's up next? So now that we've been able to get the latest high scores, so let's demonstrate that real quick. And see, we can do all that. That's great. Perfect. Let's move into sending a new player's score to the database, which is the rest of our setup here. So if we click our left button and the UID is equal to no one, so that means we don't have an ID yet. If you do have an ID, you should save it locally so that when the game starts up, it can grab that ID and stuff it into the UID variable. That way the player doesn't end up in a position where they seem to have lost their account. And again, if there is no auth request, then send an auth request. So we're going to go over to that first. Send auth request, body. To that we add a map item, return secure token as true, and encode the body as a JSON, And we also have, unlike the getting, the body in this case is a map, and it's encoded in JSON. And the header again is a map, but we don't actually encode it. We just have to include the information, content type application/JSON. Then create our request again, auth request, HTTP, auth location, post in this case, because we're sending information to the server, header map and body, dsmap replace again, add our ID to the request IDs, add our timeout to the timeouts, then destroy the body map and the header map. So now that we have sent in the auth request, then we would end up waiting, and eventually we get the information that lets us know that yes, you are now authorized. Here's your UID, here's your token, here's your auth, and all this other information. We'll get around to that in a second here. First up, we're just going to jump back to here. And if our UID does not equal no one, so if we have an ID and there is no submit request, then let's start with a get, because we want to get our current high score and make sure that we don't have a current high score, or if we do, that our current high score is less than the high score we want to submit. So let's go to get, body blank, map create, and what we're going to do here is all this stuff is the same again, but we're going to be a lot like our update here. We're going to be getting information from the server, database URL. We also include our UID in this case because we want to be getting information from the user specifically. In this case, what we're going to be doing is getting information from the score position for our UID. And we're using the shallow operative, which just sends us back the score value, which is the quickest, fastest, cheapest way to get this information out of the server. So we don't end up taking a lot of, so we don't have to do a lot of calculations or anything. That will just return to us the string with our current score in it. And so we've gone over the request, an auth request. We've gone over submit, gone over get, gone over update. So we will first go over session refreshing here. It's a lot like the timeout, basically. So if our UID does not even know one, so if we have a ID and our session refresh time, then check to make sure that our current time is not beyond our refresh time. If it is, then send in a refresh request, and set our session refresh time to no one. At that point, I'm pretty sure there's some sort of logic in there that could be improved. But we're moving on here. So refreshing our session, body grant type equals refresh token, and refresh token is equal to refresh token. This is something that we'll get in our HTTP section when we log our authorization request. Header map, DS map create, content type application, X form URL encode, request, auth request, put it into our request IDs map, do our timeout, and clean up the header map. Alright, so that should be everything covered. So, last but not least here, we need to go into the async HTTP event, which is our big potatoes setup here. So, when we send out a packet, when we send an HTTP request, I did go over the submit, didn't I? No, I haven't actually. Let's do that real quick before we go over this. Submit score. Again, it's a lot like the other ones, except in this case we're going to be packaging our name and score into a DSMap body, encoding it as JSON again, and sending out our request here. All the rest of this is the same. We have our database URL, UID, so this puts our information under our UID.json, and that tells us to put it at the head of our table. If we had subcategories in our table, we would put like users slash users.json or something like that. We also need to include our auth token so that we can actually put it in there. If we don't include our auth token, then we can't actually include it. And we use put in this case. Put is similar to a post, except in this case, what we're sending the information, we're telling it to replace the current information with the new information. So throw that into there, and we'll come back to our HTTP event. So HTTP event, bread and potatoes. When we send a request, we get an ID, and now the program keeps running, but the HTTP event is waiting to pick up any packets that are being directed back as a callback to our client here. And whenever one of these packets are picked up, it gets packaged into, all the information from it gets packaged into the async load DS map, which is a special map that only exists in the HTTP event. So we need to check that packet for information. So we check packet ID, check to see, we get the ID out of there, the status, we get the status out of there, and we filter by the status. So status 0 means that our request is complete. So you could also have stuff like -1 or 1, depending on if the packet is in progress, if you have multiple packets that are coming in for like a download, or if the thing is, if there was an error, it would give you -1, I think. But we're not going to care about those for the time being. You can throw in that logic if you feel like it. We're only caring about packets that are 0, so complete, meaning they are complete. If they are not complete, then just exit, because we don't care about the packet and we're going to discard it. We're going to ignore it. But if the packet is complete, then we need to get some more information out of it. We need to get the result, so whatever information that came from it, and the HTTP status, which is what the HTTP status code is. So there's like a 200, which is okay, or 400, 401, which is an error, denied, or 500, which is we don't know what went wrong, but something really went wrong. And you can add different, like 200, 401k, but failed because you did something wrong, etc. You can add logic for each of the various different. There's information in the system about. It says somewhere common error types that you get. I'm not seeing it in here, but probably more in here or something. You find in all this documentation there's a bunch of information about various error codes that you could get, and you could put in logic for each one of them as you need. But for the most part, you probably are going to have everything set up properly, and the most important thing you need to worry about is packets timing out because somebody lost their internet connection while trying to send information where they're just not connected to the internet at all. So then we figure out what request type we received. For the state system, we use the ID we got to find the packet type. So you remember we had the ID for the packet that we received. It should match the ID of the request that we sent out. So we can use the, so we jump into our request IDs map, loop through it, check to see if a request at a position is equal to the packet ID. And if there is a packet in that position that actually exists, then throw it into packet type as real key and exit the for loop with a continue because we found our packet here. And we'll be able to switch on that to figure out what request type we got and what we want to do with it. And jump to the next request if there's anything else in the request IDs map. If a stale packet shows up, one that was overwritten by a newer request, then we need to drop it. So if is undefined. So if we've gotten to the end of our map, our request ID map, and we didn't find a packet type that matched any of our map entries, that must mean that it was a expired packet because we've created a new packet in the meantime. And so just exit the HTTP event again. Okay, so coming into our packet types, so we have this little default thing here, mostly just for me for debugging purposes. You can throw that in if you want, but most important thing here is our request type auth, submit, get, update, and refresh. So let's start with the auth. So if we have a HTTP 200, so our packet is okay, that means everything went good. Or if we have 401, authentication denied for some reason. Main reason I'm showing the 401 part is so that you know need to remember to delete the request ID from the packet from the map, and delete the packet type from timeout timers as well. So if it and again you would put in some more information, some more AI in there if you really want. And this is kind of the same in all of these. 401 again, 401, 401, and 401. Going back to the top here. We have our packet type authorization. So if we received an authorization request, it turns out that it's good. And the results are not null because, I mean, you can get a good request, but the value of your result could be null, which means, well, I have no idea. Could be because server rules said, okay, you can't actually do this, but your packet request was received successfully, but we're sorry, we got to deny you. Something like that. this would be kind of information again where you'd be messing around, and if you find a bug, you can set up specific logic to fix that bug at that time, but it's really up to you. Should debug message, authentication successful? Probably, I hope. var result map, JSON decode result. So the result map that we got, the result value that we got in here is a map, and we have to is a JSON map, is a JSON structure, and we got to decode it into a map that we can then use to populate our information, such as our authorization token, our refresh token, our user ID, then set up a refresh time, date gets second a year, current second, plus time to live, and again, count for rollover of a year, and then some debug information for me. More importantly, DS map destroy result map, because now we don't need it anymore. And now that we have an ID, automatically send our data to the server for seamless login. Presumably, if we had no ID, then there would be no need to update our current high score. That's a little bit of pro work right there, being able to infer that they don't need a check for their ID if they had to get an ID in the first place. So we would send in a submit packet directly. And again, don't forget to reset timers and request ID. So that's everything in the in this part. So let's go over to our submission. Again, if we got a 200, we probably submitted successfully. Delete our timers information and send in an update, because we want to update our table after we submitted our information. So get. So 200, if we got null, then there was no result because we didn't have a previous high score. Otherwise, take our information, which it literally comes back as a string with just our results. So it's very easy. We just turn it into a real. And if our score, our current score that we're trying to submit, is greater than our saved score, then we submit the new high score as a submit request. Otherwise, we just don't bother. And again, don't forget to delete request IDs and timeouts. So let's move on to the update. Update our high score table. If it's a null, if you remember real-time database, this just showed null as the value when there was nothing in there. Oops. There we go. So if it's null, then it's probably an empty table. Otherwise, we're going to convert the JSON to a sortable grid and save it. And some of this information actually you probably don't even really need to do anymore if you craft a smart enough packet when you send it. But in this case, doesn't really matter too much as far as I'm concerned. So we take our results, decode it into a map, then we create a database grid, insert all the data from our map into the grid. Submap is equal to the result map key, so find our information because the score and name are kept as a map within the result map. So you have a submap there. And var underscore name is equal to our name value, score is equal to our score value. Destroy the submap. You probably don't really need to bother because you're going to be destroying the result map, which should destroy all the submaps, I believe. But I got it in there just in case. Then insert our name into our high score table. Add a table column name and our points and table points. And then we can sort our table after getting all the information based on our points column, which will give us our information from best to worst. And insert up to 10 scores into a 2D array, which should always be the max, thanks to our handy filtering rules. So if our length equals the minimum of DS grid height, so if we only had 6 scores in the grid, it would make it only 6. So if length is greater than 0, then, so if there's any actual values to insert, then turn our high score array into an actual array and insert into it our high score table and high score table, our name and points as an array. So that would create a 2D array in this case. And then we can destroy the high score table grid, and we can destroy the result map at that point as well. So it's all fun and games there. The information should all be hopefully fairly easy to understand, I hope. So let's cover that up and reset our IDs and timers again because we don't need it anymore. The packet's been used up. So let's move on to refresh, which should be our last one here. If it's null, authentication failed for some reason again. Otherwise, refresh successful, probably. And it's basically the same thing as our authorization request. After we throw in a refresh token, we get a new authorization token, a new refresh token, reset our session refresh timer, and then destroy the result map again. And reset our request IDs and timers. All right, I think that's everything covered there. So with all that information, pay attention down here over to the left. You can see all the debug information as we go. So I'm going to left click here and send a new score to the database. Connecting to the server, submit a score, fetching our new score. As you can see, sending auth request, new ID, submitting high scores, submission successful, getting the current high score database successful. And now our GML user 34 is in the database. And let's say we got a better score. Let's send in a new one. And there we go. We got ourselves a new, better score. Let's get to first place. Yay, there we go. And we're in first place. I can get the table as much as I want. You could probably set it up so that you would only do that if the array is empty. If it doesn't exist, that way you don't end up trying to... Well, like I said, you aren't giving the player actual manual control over this stuff anyways in a real game setting. So, anyways, got all our information, and I believe no way, I took that out. I had it set up so that I press shift, it would refresh the packet, but in this case, we don't really need to bother doing that. So, all right, let's zoom this out again, get back to normal there, so we can actually see all this. So that's everything. Our creation, cleanup, our step, timeouts, and that, our drawing, space, request, submission, current high score, updates, refreshing, and our HTTP. So everything's covered. With this information, you should be able to create your own setup, your own tables, send in your own information, your own authentications. Did I remember to turn that on? Make sure you turn that on and hit save. Then it will actually start putting in users. And every time a player logs in, if they don't have a UID already, you would do this. If they already do have a UID, then instead of creating a new ID, you would just send in the refresh token and refresh their session. I didn't really put in the logic for that in this case, but that would be something you would do if you want to create a persistent session. But in this case, like I said, this is basically for a high score, simple high score table for your Game Jam game, and every new run of the game would get you a new user ID, because we don't really care about the previous ID, because you're just going to be sending in a new username and high score each time you play. And you could end up with all 10 slots in your the high score table as being you, using different names and IDs and stuff if you really wanted to. But if you want to, you'd be able to load in a previously existing ID and have it only update their previous high score if you wanted to. And just there's a lot of stuff you can do with this depending on how you want to set up your system. And it's very flexible. And if you want to have a more persistent login, you could use a email password, which a lot of games do, or to get even more persistent and easier, especially if you have an Android, you would just use Play Games, because every Android probably has Play Games on it, and that would just automatically logs you in with your Play ID, or you can use a phone number or the Google ID or Twitter or GitHub or Yahoo, Apple ID, etc. There's a lot of expansion that can go into this, so I really suggest that you enjoy it and try messing around with it and do making your own project with it, because this will be a great opportunity to learn, a great opportunity to make something interesting that will make your game unique and fun for all participants of a game jam. Now, I want you. Now this we're pretty much over at this point. So, but I want you to make sure you ping me, come onto my server or something, and let me know whenever you use this to set up your own game, because I'd love to be able to see what other people are doing with my code here. And of course, don't forget to sign up for the Patreon if you want to support interesting code like this. And don't forget to also check out my other tutorials for Chip and Dale, or the Mega Man tutorial, or Legacy of the Wizard, or hopefully any of the future ones that will be coming up soon, because now that I got this done, I only have one other project which I'm kind of working on, which is actually kind of fun. It's a Warcraft 2 style AI that can actually move around properly and doesn't freak out if you click on something that you're not supposed to move into, because it actually knows how to handle it, and all sorts of smart AI movement stuff as well. But that's another project I really need to get working on. My next tutorial, which I haven't even figured out what game I'm going to be doing with yet. So once I figure that out, I should actually get started on it. So thank you everybody for watching, and until next time, good luck with your coding.